Okay, so now the software is tested. It is working fine. We have even received the acceptance testing sign off also. The user is also happy. Business user is also saying yes, it is working fine the way it should work. The next phase is deployment phase. We want to deploy our application, right? So that end users can take benefit of it. Deployment in software engineering refers to the process of making an application or software system available for use. This phase typically follows the development, testing, and quality assurance stages and involves several critical steps to ensure that the software is ready for end users. That is the typical definition. Now let's see the types of deployment. So we have, likewise we had the manual testing and automated testing. This time also we have manual deployment and automated deployment. Like it says, manual deployment involves manually transferring files and configuration settings on the server. So someone will just install those configuration files, deploy the code, right, using some commands. That is manual deployment. Automated deployment is uses tools and scripts to automate the deployment process, ensuring consistency and reducing human error. So for example, Jenkins we use for auto deployment. We know by this time, whenever is someone is creating a golden branch, then just trigger the build and the code and configuration will be automatically deployed. Let's see the deployment environments. What are those? Okay, so we have different flavors of deployment environments. First one is the development environment, then staging environment, or sometimes we call it as pre-production environment, and then the production environment. Development environment where software is initially built and tested. Usually what happens, developers, they build the functionality, they do the unit testing on their local server, local machine, and they finally push these changes to development environment, because that is basically an integrated environment for developers, so that they can validate their functionalities along with other developers, right? But kind of a mimic, not 100% mimic, but kind of replica of production environment. Production environment is of course having better CPU, better server capability, capacity, etc. But at least from integration point of view, development environment will have all the integrations available on that server, so that developers can validate it. Staging environment, a replica of the production environment where final testing occurs before going live. Usually business users, they do the final validation, they give the sign off that yes, everything is working fine. It is exact replica of production. Sometimes even the server strength, the CPU, etc. is almost same, so that we can business users or the development team, they can make sure, okay, this is how it is going to perform on actual production environment. And finally the production environment, the live environment, the actual website www.whateveryoursite.com, right, the live environment where end users interact with the application. So three environment, but sometimes we have more environments also based on different different aspects of your project. So for example, sometimes we might have a QA environment in between, so dev environment, QA environment, where the QA person, the quality assurance team, they do the validation, right? So or we sometimes we can have multiple development environments also. Consider we have different teams working for the same project. It's a big project and we have different small development team, and they are working for different functionalities, right? So sometimes we have different development environments, then QA environment, then staging environment, production environment. So it's actually based on the requirement, what kind of project we have, so we can increase the environments if needed. Let's understand deployment strategies. Okay, so we know deployment means we are installing that application on servers, like for example dev server, production server, right? Now there are different strategies we can use to deploy the application on servers. So one is blue-green deployment, then canary deployment, rolling deployment. Blue-green deployment is when we will have two identical environments. One is blue, one is green, hypothetical color code, where one is live, the other one is idle. Live means end users are using that environment. That server is being used when the request is coming. So that server is serving the request. So that is a live server. And another one is idle, means not in use. Means the requests are not being served by that server. And updates are made to the idle environment. And then traffic is switched over. So once the deployment is complete on the idle environment, then the traffic will be switched to the idle one, that will become live, and the other one will become idle, and then the deployment will happen on the other one. Canary deployment is rolling out the updates to a smaller subset of users before a full rollout to monitor for issues. And rolling deployment is gradually replacing instances of the previous version with the new version without downtime. Let's see one by one. First one is blue-green deployment. So the definition says blue-green deployment is a release management strategy designed to minimize downtime and reduce risks associated with software deployments. The core idea is to have two identical environments. So code and configurations, everything is same. Core have identical environments. The blue environment, which is live production environment, and the green environment where the new version of the application will be deployed. So this live environment, users are accessing it, will not touch it at all, and this replica of this environment, right, the new environment, the deployment will happen, and once the deployment is complete, these users will be switched to the new one, it will become live, and then this deployment will happen here. So that's why it's blue green. Let's see how it works. So the setup, you maintain two environments, blue and green, that are identical in configuration and capabilities. Deployment, when a new version of the application is ready, it is deployed to the green environment while the blue environment continues to serve traffic. Then after the new version is deployed in the green environment, thorough testing can be performed to ensure everything is functioning correctly. Then switching the traffic, once testing is complete and you are confident in the new version, everything is working fine, you switch the traffic from the blue environment to the green environment. This switch can often be done instantly without any disruption or with minimal disruption. And in case of there are any issues after the switch, rolling back to the previous version is straightforward. You simply redirect traffic back to the blue environment. So it's straightforward. Okay, let's see the blue-green deployment benefits. Reduced downtime. The switch between environments can happen very quickly, minimizing downtime for users. Easy rollback. If issues are detected post-deployment, reverting to the previous version is seamless. And testing in production, it allows for real-world testing of the new version without affecting users. And isolation of changes, it means each environment is isolated. Of course, it is reducing the risk of affecting the live applications. Now let's see the blue-green deployment considerations, what we should consider. Resource usage. Maintaining two identical environments and with the same configurations, right, that's why they are identical, requires additional resources which may increase costs. It means infrastructure, all the resources, for example, whether it's database or services, etc., it's just duplicate, right? So it will, of course, will require additional increased costs. Complexity, managing two environments can introduce complexity into deployment process and operational overhead. The overall blue-green deployment is a powerful strategy for organizations looking to improve their release processes while maintaining high availability and reliability. The next deployment type is canary deployment. Let's see what it is. Canary deployment is a release management strategy that allows you to gradually roll out a new version of an application to a subset of users. It means we have number of users coming to our application. We will divide the users, and few users will be served by this new server where we will have the deployment. Okay, new version application to a subset of users before making it available to the entire user base. The name canary, okay, comes from the practice of using canaries in coal mines to detect dangerous gases. If the canary was healthy, it indicated a safe environment. So this word was driven from there. So for example, we have version 1 and there are new changes for our application and the version 2 is deployed. So for few users will be served with version number 2, which is a new code change set with new deployment, right? And other users will be served with the uh, existing environment, existing version. Now let's see in detail how it works. So initial release, the new version of the application is deployed to a small percentage of users or a specific subset. That is why it's canary, called canary, right? Monitoring the performance and behavior of the new version are closely monitored. This includes tracking metrics like error rates, response time, user feedback, etc. Then evaluation, if the new version perform well without significant issues, the deployment can gradually expand to more users. So subset of users then will increase to more users, eventually it will be applicable for all users. I mean, that is a strategy. This can be done in stages, increasing the percentage of users who receive the update. Full rollout or rollback. If problems are detected during the canary phase, you can quickly roll back the changes for the canary group, mitigating risk. If everything looks good, the new version can be rolled out to all users. Now let's see the benefits of this deployment type. Reduced risk. By deploying to a small group first, you can identify and fix issues before a full rollout, minimizing the impact on all users. But still, because a subset of users will see the new deployment environment, and if there are issues, those users will be impacted. So there is a downside of this type of deployment. Real world testing allows for testing in a live environment with actual user interactions, providing more accurate feedback. And gradual rollout, you can incrementally increase the user base, allowing for more controlled and manageable deployment. Be cautious because this type of deployment will of course first evaluate a set of users, and like I said, if there are any issues with the deployment, those users will be impacted. So we need to be cautious if we select this type of deployment, whether our application can support that type of issue if the set of users are impacted. So then only we should go for this, otherwise we should avoid this type of deployment. Let's see what should we consider for this deployment. Complexity. Implementing canary deployments require robust monitoring and possibly additional infrastructure to manage different versions of the application. Yes. User segmentation means because we need to create subset of users, so that's why determining which users get the new version can be challenging and may require specific targeting or randomization strategies. So overall, canary deployment is a valuable approach for organizations looking to improve their deployment strategies, allowing for safer and more efficient releases. But beware that this can be an issue if the impacted user there are no ways to fix what issues the users have faced, and we should avoid this type of deployment. Let's see the next type of deployment, that is rolling deployment. Rolling deployment is a deployment strategy where a new version of an application is gradually rolled out to servers or instances in a controlled manner. So earlier was for a subset of users. This time we have for servers. So we will gradually increase that deployment to servers. Instead of updating all instances simultaneously, so for example there are five servers of the application. So first we will deploy it on one server, then another one, then two, then three, and so on. So gradually we will increase deployment to all the servers. So instead of updating all instances simultaneously, a small subset of instances is updated at a time, allowing for continuous availability of the application during the deployment process. Let's see how it works. So incremental updates. The new version is deployed to a small number of servers or instances while the rest continue to run the current version. Okay, so for example, if there are 5, 2 will be updated, but rest 3 will still be behave with the old version, with the current version, or we can say current version. This process continues in batches until all instances are updated. Monitoring. As each batch is updated, the system is monitored for any issues such as performance degradation or errors, and this allows teams to catch problems early. Rollback capability. If any issues are detected during the rollout, the deployment can be paused or rolled back for the affected instances without impacting the entire application. So for example, so since we have batches, right? For example, for my application, I will have 5 batches. I have 10 servers, and then each batch is having 2 servers, right? And I see there is an issue with the newly deployed batch. I'll just roll it back. I'll just roll back that. And there is no impact on the rest of the 4 batches. Completion. Once all instances have been successfully updated and are stable, the deployment is considered complete. Let's see the benefit of this type of deployment. Minimal downtime. Since only a portion of the instances is updated at a time, the application remains available to users throughout the process, right? Because it is like batches, so still the other one which are not updated with the current one, they will serve the request. Risk mitigation. Problems can be identified and addressed early in the rollout, reducing the risk of widespread issues. Controlled rollout. The pace of deployment can be adjusted based on the performance and feedback received from the updated instance. So those are the benefits of this type of deployment. Now let's see what should we consider for this deployment. Complexity. Managing multiple versions of an application can complicate testing and monitoring. So consider, we will roll out it for batches. So first batch, then we need to validate it. Second batch, okay, we need to validate, right? State management. If the application has stateful components, for example, I have a login feature, so my session should be maintained and I am navigating through the application, so from one page to another page, right? My session should be maintained. So that is kind of stateful web application. So if the application has stateful components, ensuring consistent state across instances during deployment can be challenging. What does that mean? So for example, the request is going to one server. So there are 5 servers and request is going to first one server, maybe instance number 1, and then I have logged in, right? Now the second time when I'm refreshing the page or I'm going to another page, this request is going to another server number 2. Now this server should understand that I am already logged in. So with the next time I refresh the page or I go to another page, it should not ask me to log in again. That is kind of stateful application. So what it says, state management is kind of little bit challenging because we have batches of our instances, and consider we have 5 batch, 1 batch is updated with the latest version, other 4 batches are still with current version, and the request is being served first using the first instance which is having current version, and after that the request is going to one of the instance which is having the latest version. So how we are going to manage this state, that is a little bit challenging. Okay, user experience. Depending on how traffic is routed, some users may experience different versions of the application, which can lead to confusion if not managed properly. Consider we have just rolled out a new web page, and this web page is only available of course because it is batch wise, right? And you just refresh the page, okay, see this new page is coming, new user experience is coming, but at the same time when the user is going back, navigating back and coming back again to the same page, it's gone because it's giving now 404 error, because now the request is being served by another server where we do not have this deployment done so far, right? So those type of user experience issues we might face. Overall, rolling deployment is an effective strategy for maintaining application availability while introducing new features or fixes, making it popular in environments where uptime is critical. Now let's see, once the deployment is complete, there are few activities which are called post-deployment activities. What are those? Monitoring, so continuously observing the application's performance and user interaction to catch any issues early. So basically see the server load, if there are no errors on the server, all the metrics is working fine. We have different tools available for that, for example New Relic, CloudWatch logs from AWS, right? So we monitor the web application, see if there are any issues related to CPU utilization, any issues related to performance, those any issues related to security. So those things comes under monitoring part. So we monitor the application because it's just deployment just happened. Then feedback collection, so gathering user feedback to identify areas for improvement, right? Then maintenance, regular updates and patches to address bugs, improve performance and add features. Sometimes we provide hypercare support also to business. So for example, right after the deployment, there will be 2 weeks of hypercare where if we get any type of issues, we will fix it. There will be an SLA defined that within 1 day, within 1-2 hours, based on priority of that defect, right? The fix will be provided and will be deployed again to the server, right? So those things comes under maintenance.